Alrighty, hello, lovely unites. This is the last part to factorization with the quadratics and difference of two squares. And so basically it's combining this with algebraic fractions. And so basically this part, it combines both your knowledge of fractions with your knowledge from 4a to 4d. This section can initially be pretty tricky because it requires both strong skills with both your fractions and your algebra from chapter 4a to 4d. And yeah, so I'm just going to try and highlight a few points first up. So let's just think about just a simple fraction here. So 15 over 20, and you might go, well, that simplifies down to 3/4. Now, why does that work? Well, because 15 is the same as 3 times 5, 20 is the same as 4 times 5, and well, those 5s cancel out. So now why can we cancel those out? Well, because they're factors of both 3 and 4, and you can cancel out factors, okay? So you can't cancel out things that add to one another, but things that multiply by the other term there. So I can cancel out those two 5s there like so. Now, in this next example below, I've got two binomial products, x take 4, x take 1 over x take 4, x plus 2. And in much the same way as the previous example, I can go, well, x take 4 is a factor, x take 4 here is a factor. So actually I can cancel out all of those ones there. And what am I left with? I'm left with x take 1 over x plus 2. So we can simplify an algebraic fraction down like that there. So let's come down to some slightly more trickier ones. Okay, so in this first example 12 we've got here, x plus 1 over x squared plus 3x plus 2. I just can't simply go, all right, well, I can cancel out those two x's there like that. Firstly, we need to identify factors for both the numerator and the denominator. So that x plus 1, I can't do anything with, so I'm just going to keep it as it is. I'm just going to write down x plus 1 first up for my fraction. However, for the denominator, I can factorize that like in chapter 4c. So that actually becomes x plus 1, x plus 2, like that there. And then here I can say, oh, well, the numerator has an x plus 1, the denominator has an x plus 1, and you know what? I can actually just go ahead and cancel down those ones there. And in doing that, what I'm left with is a 1 over x plus 2, like so. So x plus 1 is a common factor to both the numerator and denominator. Let's have a go at the second example here. So again, what we want to do is we want to factorize both the numerator and denominator. So for this first one, I want to think of factors of 12 that add to minus 4. And you're going, oh, what could that be? So we've got here 1 and 12, 6, 3 and 4. And actually, yeah, it's going to be 2 and 6 there. So it's going to be positive 6, negative 2. X plus 6, x take 2. And then let's do bottom one here, factors of 10 that add to minus 3. So we've got 1 and 10. 5. All right, yeah, it's going to be the 2 and the 5. So I'm going to get x plus 5, x take 2. Okay. Now, I couldn't initially go, oh, I'm going to cancel out those x squareds there. I'm going to cancel out those x's there. It doesn't work like that. You need to figure out what are the common factors for both the numerator and denominator. We can go, all right, well, here in this new fraction we created, we've got here x squared, x take 2 and x take 2. It's both a factor of both the numerator and denominator, so I can cancel it out. And that just leaves me left with the x plus 6 over x plus 5. And so I'll just write that out, x plus 6 over x plus 5. And then I'm done there. I've simplified that particular fraction. Now you can actually test it out to see if you've done it correctly by substituting in a particular value. So for example, in this first one I did here, example 12, to say let's put a 1 into this equation here. So if we put in x is equal to 1, what are we going to get? 1 plus 1 is 2, 1 squared is 1, 3 times 1 is 1, so 1 plus 3 is 4, 4 plus 2 is 6. It gives me 2 6, which is equal to a third. Now let's put an x is equal to 1 into here. Well, that's just going to give me 1 over 1 plus 2 is 3. It also gives me a third. So you can test to see if you've done your simplification correctly by substituting in a particular value and checking to see if it works. And the same would apply for example 13 here. You know, if you put in, you know, a value into both of those, you should get the same value. Actually, let's test it out. Let's put in x is equal to 0 into this one here. You would get minus 12 over negative 10 if I put it, which simplifies down to 6 over 5. Let's put an x is equal to 0 into here. And what do we get? Yep, 0 plus 6 is 6. And 0 plus 5 is 5. Yep, you get the same fraction there. So put anything in, and then you know you're on the right track. Cool. Alrighty, good luck with those, guys.